Hello, welcome to this video tutorial all about simultaneous equations today. Now, the aim of a simultaneous equation is to solve two equations at the same time so that they have exactly the same answers. Now, if we take an example such as y equals 2x plus 4, this is one equation and it has two unknown quantities in it. We have here the y and the x. Now, sometimes if we just have the one equation on its own, just like this, we can say, well, I'd like x to be a number, and you can choose a number, anything. So let's just pick any random number, say 5 in this case, and then we'd be able to find out what y is by substituting the value of x into the equation. So this would turn out to be y equals 2 times by 5 plus 4, because this x is a 5. And then we'd be able to find nice and easily that y would be equal to 14 in this case. So that's with a single equation on its own. But what about if we have another equation that we need to solve at the same time so that both equations have exactly the same answer? So let's put another equation up on the board. So y equals 6x take away 8. Now, our previous example, or previous attempt at an answer by saying that x equals 5 was fine for when the equation was on its own, because we said that x was 5 and y was equal to 14. But that's only for this top equation here. But what if we had that same x equals 5 in the bottom equation? What would happen? Well, this x here, this 6 times by x, would be 6 times by 5, which is 30. And then we take away 8 to make y equal to 22. Now this 22 and the previous y of 14 for the top equation don't match in value. So this actually means that our guess of x equals 5 is not correct for the simultaneous equation pair. So what we need to do is come up with a different way of solving simultaneous equations, or two equations at the same time, so that both x and y values become exactly the same. So let's look at the method and how to do this. First of all, it's almost like you need to be aware of column subtraction. So let's take 2x plus 4 and this 6x take away 8 and just put them above each other, so that we have these columns. And if we were to subtract this, the answer actually becomes y take away y, because we've got this y and now we're removing or taking away this y. So when we have one y and we take away another y, it becomes 0, or 0y. Then we have an equals sign, and then we do this 2x take away 6x. So when we do 2x take away 6x, we have minus 4x as the answer. And then lastly we have this plus 4, and then we're taking away minus 8. So this is where negative numbers becomes really important, because we've got plus 4 take away minus 8. So these two minuses actually transform into a positive sign. So it's plus 4 plus 8, which makes positive 12, or plus 12. So what was the aim of doing all of this, taking away this column subtraction with equations this time? Well, before we had two unknown quantities, the y and the x, in both equations. But now, by removing these, we've actually removed the y value from the final equation that we've just calculated, and we only have an x left, which actually means that we can solve the value of x on its own without needing to worry about y. So let's just take this equation here as a normal two-step equation. So we have 0 equals minus 4x plus 12, and what we'd like to do is solve this. So we'll just go ahead and solve this in the normal way for a two-step equation by removing the 12 first. So we have minus 12 equals minus 4x. If you need to look up on how to do a two-step equation, you might want to look at one of the other videos and have a practice first. Okay, so the next step is this minus 4. We want to remove that, and that gets removed by dividing by minus 4 on both sides. So minus 12 divided by minus 4 equals x. So negative negative makes a positive, 12 over 4 makes 3, so x is equal to 3. So this should be correct if we've done it all right. This x equals 3 or plus 3 or positive 3 should mean that the y values for both of these equations, the original equations that we had, will work. So let's just go ahead and use that x equals 3 for the first equation. So y equals 2x plus 4, so that's 2 times by 3. Remember, the x is now a 3 because we've solved it for a 3. And then we're going to add 4. So 2 times 3 is 6, plus 4 is 10. So there we go. So it says y equals 10. Now, if we've done it right, as I mentioned, then this second equation should also give us the same value of y. So remember, 6 times by x, x was 3. 6 times 3, take away 8. So 6 3s are 18, take away 8 is 10. So there we go, y equals 10 for the second one as well. So that just proves that these two are both the same. Therefore, we've solved the simultaneous equations correctly, and we can now go ahead and write our answer as x equals 3 and y equals 10, because when we use x equals 3 and y equals 10 in both equations, both original equations here, they actually solved to be absolutely correct. So that's one example. We'll delete that and have a go at another one now, and hopefully be able to run through it just a tiny bit quicker. So 8x take away 9 and y equals 5. Y equals 5x take away 3. Okay, so we're going to do this in the same way. Remember, we started off by taking away the column subtraction of both equations. So this y take away this y makes 0. This 8x take away 5x makes 3x, and then minus 9 take away minus 3. Remember, those double minuses make a plus, so it's minus 9 add 3, so that makes minus 6. Okay, so 0 equals 3x minus 6. So if we were to just go ahead and solve this as two-step equation again, it makes 6 equals 3x, and then 2 equals x. So we found out what x is now, and now we're just going to pop it into one of the two equations, although I'm going to do it in both just to prove that whatever equation you use, you should get the same value of y. So 8 times by 2, remember that 2 is the x now from this equation, and then we're going to take away 9. 8 2s is 16, take away 9 is 7, so y is 7. Now if I just go and do it with this one in the same way, we should find that y equals 7 as well. So 5 times by 2, take away 3. 5 2s are 10, take away 3 is 7. So there we go, done it correctly. However, if you ever did get two different answers for these two, if you try both ways, and you get a different answer, then it generally means that you've made a mistake in calculating x, or you might have made a mistake here with the calculations, but you just need to go and double check and be extra vigilant. So for this example, just to tidy it all up, we'd say that x equals 2 and y equals 7. So the answer for the simultaneous equations always has a value of x and a value of y. Okay, so that's what we call simultaneous equations by subtraction, or sometimes we might use addition when we do some column addition instead. It does get harder though, unfortunately, but not too much harder. So I'm going to put another example up on the board and we'll explain why it's harder. The easiest way to explain this, for the reason why it might be harder, is just to have a little look and see what's different. Well, hopefully you might have spotted that in front of the y we've got this 2 now. It doesn't make a huge deal of difference, but it does mean that when if we were to just subtract as it is, then what we end up with is y, because 2y may take away y, and then equals x, or 2x plus, in this case, 9. 2x plus 9, and we haven't actually got rid of a y or an x, we've still got them, which means that we can't actually solve a two-step equation because we've got two unknown quantities. So the way in getting around this, when we've got different values here, and just get rid of this, when we've got a different value other than 1 in front of the y, or for instance when the values of y are slightly different, this is a 2y and this is a 1y, we need to be able to make them the same. So the way to do that would be to multiply this one by 2, because when we multiply this one by 2 we get 2y equals 2x take away 10, because we're just timesing every term or every value of the equation by 2. So this y becomes 2y, this x becomes 2x, and this minus 5 becomes minus 10. So that's what we've got here. Now if I were to then just put that other equation, the first equation, above that, we can now hopefully see that the y values are exactly the same. So when we take them away, 2y take away 2y makes 0 again, which is always the thing that we're after. We're after removing at least one of the letters, generally the y, but you can always do the x if you wish to. So from taking away the y's, now we go over to the x's, and we're going to do 3x take away 2x, which just makes 1x, and then we're going to do plus 4 take away minus 10. Again, those double negatives, so we've got this negative here and this negative here, so that actually makes a plus 10. So 4 plus 10 is 14. So from here we've now got this equation that we've just made up. Only got one unknown quantity, just the x. The y has actually gone because we multiplied that first one by 2, so that the values of y become exactly the same. So now we're going to solve for the value of x. So we just want this x on its own, so it just means we need to remove this plus 14, which actually makes x equal minus 14. So hopefully, if we've done our sums correctly, this is going to work for both equations. So you can actually just choose one equation to then go and calculate the value of y. So I'll do the harder one first of all, is 2y. So 2y equals 3 times by x. X is minus 14, so I'll just put the minus 14 in brackets. Always good to remember that it's a negative. Then we're going to plus 4. So 2y equals, well, 3 times by minus 14 is minus 42. And then we're going to add 4. So 2y equals minus 38. And therefore y equals minus 19, because we just divide by 2. Okay, so hopefully, if we've done that correctly, as we mentioned before, if we take the first equation, one of the other equation, the second equation, y equals x minus 5. Remember, x is minus 14, and then take away 5. So that makes minus 19. Minus 14, take away another 5 is minus 19. So there we go. Y equals minus 19. Got the same from both, so we know that we've done it correctly. Okay, so that's slightly harder simultaneous equations. There is another way of solving these, which is through substitution, what we call substitution method. The one that we've done so far, as I mentioned, is just called the addition or subtraction method, because we're subtracting, or sometimes we might want to add the two equations together in order to remove one of the unknown quantities. So I'll just write that exact same question up again. 3x plus 4, y equals x take away 5. Okay, so what we're going to do now is look at the substitution method, which if we look at what the value of y is, y will be a number, but it is also an expression. We found this expression here. In fact, it's already been given to us. Y is x minus 5. So wherever there's a y, we could just say that that's the same as the value of x, which we don't know, take away 5. So let's take the first equation, the 2y 3x plus 4. Let's look at this y. Instead of that y, I can just say that I'm going to put an x minus 5 instead, because y has to be the same as x minus 5. So if I were to just say 2 times by x minus 5 instead of that y, because we're just replacing it, that would be equal to 3x plus 4 as well, because all we've done from here is substituted this y for this x minus 5, because that's what this equation says. Okay, so from here, what we're going to do is tidy up, expand the brackets, and hopefully be able to solve. So first thing we'll do is expand the brackets. Whenever you've got an equation with brackets in, it's always useful to try and expand the brackets out. So 2 times by x is 2x, and 2 times by minus 5 is minus 10, and that would be equal to 3x plus 4. There we go, just expanded the brackets there. And then this becomes just a linear equation where we just need to collect the x's and the numbers together on different sides of the equal sign. So just choose a side for the x and choose a side for the numbers. Generally I pick the side for the x where it's got the most amount of x's to start with. So this 3x I'll choose as the x's side, and in fact I'll just write that here. So on the right we're going to have the x's, and on the left we're going to have the numbers. Okay, so from here we've got minus 10 on the left, but we're going to move this plus 4 over, or remove it from the right hand side, which means we're going to minus it on the left. Don't forget we had that 2x, and now we've got this 3x here. So all that's happened here is we've removed this plus 4 by taking away 4, and there it is. Okay, so now we're going to either tidy up the numbers bit, or remove the x's onto that side. Totally up to you what way you do it. I generally tend to move the x's first. So we've got minus 10, take away 4. This 2x is going to be removed by minusing 2x from both sides. So then what we have is 3x minus 2x on the right. So there we go, we've got all the x's on the right and all the numbers on the left. So now we're just going to tidy up. Minus 10 minus 4 is minus 14. 3x take away 2x is x. So in fact here, what we've done is found x already. We don't need to do any dividing, because it just says 1x equals minus 14. From here, we can then just go ahead and use one of the original equations. Y equals x take away 5, so x is minus 14, take away 5 makes minus 19. And we know that's correct because we've already done this. It was the last question that we did. Y is minus 19, x is minus 14. So that's the substitution method. Okay, so that's the substitution method. Hopefully that makes a bit of sense. Have a look at the downloadable documents on the library and give it a go yourself. So the next thing that we're going to look at is obviously still simultaneous equations, but we're going to look at another concept. So far what we've done is looked at the addition or subtraction method. We've looked at the substitution method, which was the last one. And the next method that we're going to look at is the graphical method, or graph method. So without further ado, I'll just write down a question, and then we'll just start going through the graph method, because it's much easier to just show rather than try and explain without any graphical illustration. So x minus y, and then x plus 4y equals 11. So with the graphical method, the aim of it, if you think about it, we've got a value for x and a value for y. We don't know them at this stage. But if we were to, say, draw a graph for this x minus y, then, you know, we'd have, let's have a look, what would it be? It would look something like this. Okay, and somewhere along this line, we'd have the values of x and y that we're going to solve for. If we were to we could do this using the addition, subtraction, or the substitution method if we wanted to. But ultimately we're going to have a value of x and a value of y, and on a graph that would just be a point along the graph, along the equation's graph line. So this straight line here, we'd have a value of x and a value of y, and that would be our solution somewhere along there. But when we add this x plus 4y in, what we end up doing is creating another graph or another line, and these two lines will cross somewhere. Now this is not going to be accurate, but if I just put another line in there, then we have a line, the two lines are crossing just here, and where they cross is actually going to be the solution. So what I'm going to do is remove this, and there we go. Here's a graph that I've already made for this. Again, this is the simultaneous equations video and demonstration. It's not about drawing graphs. We won't be looking at how to draw a graph here. That's for another video and another lesson. But hopefully, if you're confident with drawing graphs, you'll be able to draw the one graph for this one here, which is the red. In fact, the red one is here, and the blue one is this one. So we just draw both of those graphs on the same axis, and then we see this point here is where they cross, and this will be the values of these x and y's for the solution. So if we just go here and using a nice straight ruler, obviously, should have done this a tiny bit bigger, but we can see the value of y is somewhere here, somewhere between 5 and 0, so somewhere, let's call it 2, and then the value of x is somewhere between 0 and 5, a bit further over halfway, so maybe 3. So that's what it roughly would look like. But the downfalls to this method are that, as you can see, if you don't draw a nice big graph, like what I've just done here, then as you can see, what I've done is not quite as accurate as what you might hope. So the aim of it would then be to draw another graph, or to do it more accurately in the first place rather, so we can find the values of x and y more accurately. But even so, the idea of this relies on you to have a very keen eye, a very good drawing skills, a nice straight ruler, a sharp pencil, and so on and so forth, all the good things involved with graph work. But even so, it's only going to be as accurate as you can see with your eye. So the other methods, this substitution, the addition and subtraction methods, are generally a bit better for this. But even so, we can get a good idea of roughly where the numbers should be by the graphical method, and you do need to be able to do that. So that's the graph method. Just to recap, draw the graphs of both equations, where they cross, find the x and y coordinates, and that's what we get as the answer. But remember, you do need to be accurate, as I've already mentioned. Okay, so far what we've looked at is linear equations. And what I mean by linear equations, as you just saw on the graph, they are equations which draw a straight line. They're not quadratic. Quadratic graphs generally, in fact, they're pretty much always curved. Curvy lines looking like a U, sorry, not quite like that, a U or an N or something along those lines. Okay, so when we have simultaneous equations and we want to look at quadratic simultaneous equations, quadratic and linear, it becomes a bit harder. So, and this is where the substitution method for what we looked at before is very, very good. So what do we have? X squared plus 11x plus 9. So something like this. We've got a linear here and a quadratic equation here, which is very different, because when we take away or substitute one equation into the other, or something like that, one of the other methods that we've done, we end up with a quadratic equation, not a linear equation. But it doesn't make loads and loads of difference. Let's have a look. So what I'm going to do is just no, in fact, what I'm going to do is substitute. I'm going to use the substitution method so you get an idea of how that one works as well, just as a recap. So again, just to recap here, this y is saying that it's equal to this 6x plus 3. Okay, so wherever there's a y in the other equation, we can change it for a 6x plus 3. So with this equation here, I'm going to change this y for a 6x plus 3. So on the left, I'm just going to have, 6x plus 3. And on the right, we have x squared plus 11x plus 9. So what's happened here? Well, let's just change that a bit. Well, we've got no y's left, but just x's. So we need to try and solve this. So the most important thing to realize is that this x squared makes this a quadratic equation. So in order to solve a quadratic equation, we need all of the x's and all the numbers all on the same side of the equation. So we want 0 equals. So here we go, 0 equals, which means that we need to remove this by minusing 6x, and we need to remove this by minusing 3. So we'll do that to both sides, and what happens is we get x squared plus 11x plus 9 minus 6x minus 3. And now we just need to collect the terms together. So this 11x take away 6x equals 5x. And this plus 9 take away 3 equals plus 6. And then we have x squared here as well. So we've collected these two and then collected these two. And then we've obviously got the x squared still. So what we have now is a very similar situation to what we'd have in a linear, where we've substituted it, and then we've realised that we've had a quadratic, which is where it starts to differ slightly. So we've got a quadratic, we move all the stuff onto the same side, and then we've got this final quadratic equation here. And in order to solve this, you do really need to be up to speed on how to solve a quadratic equation, either by factorising, or by using a formula, or by completing a square, or something. Any method possible you can use to solve this quadratic equation. So I'm just going to go ahead and solve it. I'm not going to explain too much and dwell on how to do it too much, because that's for another lesson again. So plus 6 plus 5x, so I know that this must be x plus 2 and x plus 3, because 3 times 2 is 6. 3x plus 2x makes 5x, and then we've got the x squared. Okay, so how do we solve this? Well, we need to say that x plus 2 equals 0, or x plus 3 equals 0. Again, if you're not quite following, you'll need to go back and look at how to solve a quadratic equation. This generally means for this one, x equals minus 2 or x equals minus 3. So now we've got two values of x, minus 2 or minus 3. But what about the values of y? Well, we're going to have two values of y as well for both of these. So when x equals minus 2, what does y equal? Well, that's where we just go back to our original equation. Take this. Y equals 6 times by x, which is now minus 2. So I'll put that in some brackets. And then we'll add 3. 6 times minus 2 is minus 12, plus 3 is minus 9. So y equals minus 9. So when x equals minus 2, y equals minus 9. But what about the other value of x that we had when x equals minus 3? Well, again, we'll just take that same equation, 6 times by x, which is minus 3 now, and then we're going to plus 3. 6 times by minus 3 is minus 18, plus 3 is minus 15. So now we've got a value of y for when x equals minus 3 and a value of y for when x equals minus 2. And that means that we've got two solutions, or two sets of coordinates if you kind of think about it in a graphical sense on a graph. We've got when x equals minus 2, y equals minus 9, and when x equals minus 3, y equals minus 15. And the reason for, let me just get rid of some of this. The reason for having two sets of coordinates, or no, we don't want to get rid of that, or two sets of answers, is because if you do think about it in a graphical sense, here we go, I'll just draw a graph very quickly. What we'd have is, one second, this quadratic equation here, which would make a curved line, so a curved line somewhere, let's just call it something like that, and then this linear equation here, which would be a straight line. So there's a straight line. Now we get 2 points of crossing. 2 points of crossing means 2 sets of coordinates. There's one set, and there's another set. I do appreciate that my drawing isn't quite as accurate as if I were to really study the figures and draw the graph correctly, but this is just more of an illustration really more than anything, just to prove that a curve and a line generally will have 2 intersection points. Okay, so that is simultaneous equations using quadratics and linear. It's quite a tough topic, so give it a go. Get some graph paper, a ruler, sharp pencil, and see if you can draw it as well, and find the solutions of these, as well as being able to do it algebraically. So anyway, that's the end of simultaneous equations. Do please practice and use the resources on the library. Thanks very much. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah, would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give that another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done. That's good.